Good afternoon, everyone. Today we're going to learn how to write the equation of a linear relationship. So you all have this sheet in front of you right now, or you should. It's called Food Frenzy, and the title of the worksheet is Modeling Linear Relations with Equations. So the question asks, write the equation for each relationship in the space provided. Show any calculations you made and indicate if the relation is partial or direct variation and whether the line modeling the relationship is solid or dashed. Okay, so the first question, number 1, says a family meal deal at Chicken Deluxe costs $26 plus $1.50 for every extra piece of chicken added to the bucket. So the first thing we want to do is we want to write our equation. Our equation, we know, is in the form y equals mx plus b. Okay. Now, our y variable is our dependent variable. In this case, our dependent variable is the cost. So I'm going to represent cost of the meal deal, which is C. Okay. M represents our slope, or our rate of change. The rate of change in this case is $1.50 for every extra piece of chicken. Times x, the number of pieces of chicken, plus the initial cost of the bucket, which is $26. Okay, now I have my equation. Now, in this case, I'm not going to use x, I'm going to use n for the number of pieces of chicken. So my equation is c equals 1.50n plus 26. Now the next part of this question asks, is this relation a partial or a direct variation? Well, because it has an initial cost and it has a rate of change, this would be an example of a partial variation. Okay, now I would like you to stop the video and try to solve number 2 on your own. Okay, when you restart the video, you should come out to the following equation. C equals 11n plus 24. And once again, this is an example of a partial variation. Hopefully you got the correct answer. Moving on to the next question. If you need to stop the video, please do and review this first part again. Next question, number 3, total cost of submarine sandwiches. So we have an example of a graph here. Now the question is, once again, we need to come up with an equation. And once again, our equation has to be in the form y equals mx plus b. Okay, so we're talking about our y variable here is our dependent variable on the vertical axis. It's total cost. So I'm going to use C to represent total cost. Oops. Okay. All right. Now my slope in this case has to be my rate of change. So my rate of change, I'm going to choose 2 points on the line. I'm going to choose this point right here, which is 0 and looks like 2.5. And I'm going to use this point right here, which is 1 and 7.5. Okay, now between those 2 points, I need to find my slope. I need this m value. So I'm going to find the rise and the run. So the rise here is 7.5 minus 2.5. So the rise is 5. The run is 1 minus 0. So the run is 1. So slope, the m value, which is the slope, which is the rate of change, is equal to rise over run, which in this case is 5 over 1, which is equal to 5. What does that 5 represent? Basically means $5 for each submarine sandwich. Okay, and so the cost here is 5 times x. In this case, I'm going to use n. N is the number of submarine sandwiches. There's n. 5n plus the initial cost. In this case, the initial cost is the cost of delivery. And since the graph starts at 2.5, it would be 2.50. So the cost of submarine sandwiches with the delivery charge, initial delivery charge of $2.50, would be C equals 5n plus 2.50. Now the next question is, would this be a direct or a partial variation? Well, because it has an initial cost and it has a rate of change, and you can see the graph starts not at 0, but it starts at 2.5. So this would be an example of a partial variation. Okay. Now I want you to stop the video and try and complete number 4 on your own. Okay, now that you're done number 4, I'm assuming you've stopped the video. You should get for your equation C equals C equals 2n plus 2.50. And this would be an example, once again, of a partial variation. Okay. Last question. Now we're going to try and write the equation using a table of values. Okay, number of toppings and cost of a large pizza. Again, our equation has to be written in the form y equals mx plus b. So again, the y variable, again, y is the second column, x is the first column in the table of values. So my y would be the cost of a pizza, C, equals my slope. Well, this time I need to use my slope. I need to calculate my slope here. I need to calculate using the slope y2 minus y1 formula over x2 minus x1 formula. So I'm just going to open up a new page here, and here we go. So my slope is equal to y2 minus y1 divided by x2 minus x1. Okay, so that's going to equal, so my y2, I'm going to choose my first 2 points from this table. So my first 2 points, my first 2 y points are 11.50 and 9.40. So y2, this one, minus y1, this one. So let's go to my other page. 1150 minus 940, I believe that was correct, equals 940, okay, equals 210. Okay, and my x2 minus x1, okay, is equal to 1 minus 0, which is equal to 1. Okay, so my slope here is going to be equal to m equals my rise, which is y2 minus y1, which I worked out to 2.10. So I'm going to write that out, 2.10 divided by my run, x2 minus x1, which is 1 minus 0, which is 1. So my slope, or my rate of change in this case, is 2.10. Okay? So let's go back here where I started writing my equation. Now c equals my slope, which is 2.10. Now instead of x, I'm going to use n, the number of toppings, n, plus, oops, I made a mistake here. That should have been plus b. Okay, n, my number of toppings, so c equals 2.10n plus my initial value. My initial value in the table of values, because 0 is the number of toppings, the initial cost of the pizza is $9.40. That's without any toppings. So if you don't get any toppings, you still got to pay $9.40. So plus $9.40. Okay, perfect. Now I want you to stop the video, and I want you to try and complete number 6 on your own.